So this is how I imagine you will become after you take this home and learn it, try it out. And this is the boost of productivity that this session will give you. And if it doesn't, tweet at me and you can insult me later. And this is a loop, so we can stay there and look. And it will go on and on. And on. So I put it on repeat. So apart from the jokes, I thank you for laughing. I see a lot of, that worked very well. I have 3 topics for you today. We'll go a little bit in details into each of those 3. So the first one is, how do you handle project dependencies of sub-projects if you're using Git? So there's many ways to do it, and I'll have a big disclaimer at the end of this. But today I'm going to show you one Git command, which not many people know. It's called the Subtree, that allows you to inject a dependency, an external repository, into your Git tree at any given point, whenever you need it. So that's one of the topics. It has a lot of pros, some cons. You need to know when to use it, and hopefully I'll explain you when it's a good choice to use it, when not. And personally, I find it really cool. The second one is a technique that I see a lot of my colleagues, expert developers, expert Git users use all the times, but maybe other people that are not that familiar with Git don't use. And it's how to do interactive staging or interactive commits, interactive adds. So it's that technique where you're working on one feature, but also you can fix something else that's related to a bug, and it's in the same file. And then you have the question, shall I commit it all in one commit? How do I split this in multiple commits so that it actually makes sense? And when somebody looks at those commits, they can understand exactly what I did. So interactive commits, interactive staging, that's what it gets you. And I want to show you an example, a demo. We walk through an example of how that's done. I think it's a very powerful technique, and I'm sure you will enjoy it. And third, it's a topic for specific needs, and just to show you how flexible and powerful the Git commands are. So there's many Git commands, and in this specific section, we'll talk about Git replace. And now you're able to, if you want to, replace any Git object, any Git commit with any other, and why that will be useful. So those are the 3 topics that I have for you today. And I'd say, if you agree, we start with the first one, which is Git Subtree. So I told you, Git Subtree, this very new thing. It's actually not that new. Git Subtree has been available in Git since version 1.7.11. So it's been there for a while, though it's one of those things that not many people know about and not many people use yet. What is it good for? Well, it allows you to pull the source from another repository and place it in a folder of your project. With various different options available, very different flags. And it allows you, which is another very useful feature, to extract a folder in your project and make it a separate repository. So imagine you've been working on this project, which is a massive monorepos for a while, and then you realize that actually some of the libraries or some of the client source that you have might be better if you actually split it out. And so Git Subtree makes it incredibly easy to take a folder of your project and move it out of your repository and track it separately. So I'll show you also how that's done and how does that works. Now let me tell you a few reasons why you want to use Git Subtree instead of other options that are available. The first one is that Git Subtree stores everything that it imports in normal Git commits. So this means that whoever types these Git Subtree commands, only he needs to know them, and the rest of the team doesn't need to know these Git Subtree commands. So the rest of the team can keep working, and the guy that manages the dependencies, updates the libraries, is the only one who needs to know about these Git Subtree commands. From the average user, for the user of the parent repository, they're just regular commits. And that sometimes can be a big win. The other reason, I just said it, second really good win of Git Subtree compared to, for example, Git submodules, is that Subtree stores all the operations it does in regular Git commits. So it's compatible with any versions of Git, and what's happening is actually stored in the history of your repository. So it's very transparent and very clear what's happening. And third, because every time you update a library, a dependency, a sub-project, it's storing commits, it's very easy to see what happened when. It's very easy to go through the history and say, we updated this library that time to version X. Okay, that's very easy to grasp. So those are 3 big pros of using Git Subtree. Let me show you very easily, simply, how that works. We start from first command. How do you start? Say you have a dependency that you want to import in your repository, and you want to keep it up to date. The first thing you do is you add a subtree. So how do you add a subtree? Let me break it down for you. Maybe if I'm covering the screen, I jump down. You type git subtree add, where add means, OK, add this folder and pull the source for that folder from, put it in this folder. We call it target folder. So you say -- prefix target folder. You specify the repository where you want to pull that source from. And then you specify which branch or which tag you want to pull those sources from. So if you like to pull a dependency from master, and then you can type master. Most of the times here you actually want a certain tag so that you know exactly which version of that dependency you pulled. And the final bit there, you see squash. It's there to tell Git to take all those commits, squash them into a single one, so that in your parent repository, you only have one commit that contains all that source. This is useful from the perspective of the parent repository because you don't get all those 50 commits that make up all the history of your child project. How does Git Subtree keep track of what it has already imported up to which version? It adds a little bit of metadata to those commits. So when you use Git Subtree, you get a normal Git commit with just some annotated metadata here. So it says, I have injected some source at this folder, and I have, pulled up to this commit ID. So that is going to be used by Git Subtree also to do updates, and it's for you also if you need to investigate what's happening. So when you do the Git Subtree add, what happens actually, you get 2 commits. A commit that I just showed you with where the source code was injected and what revision was injected from, and a merge commit so that you know that some code was merged from somewhere else. After a while, you want to update that library, that sub-project. How do you do it? You do it with Git Subtree pull. So you do Git Subtree pull, which is the command of the Git Subtree. You specify the folder where you had injected that sub-project before. You specify the same repository from where you were getting those sources. And again, you can specify from up to which release you want to pull the sources to. It could be master, but it could also be a certain tag from that project. And again, you don't forget to add squash, otherwise you get a long list of commits taken from that child project. So under the hood, as I said, just store some metadata in the commits. And if you see there is this unique identifier for the commit from the child repository, how do you know exactly which version that is if you have to look at it? So I'll give you a tip on how to do that. You can do that by using a command called lsremote. lsremote lists the symbolic names of a remote repository. So it's a Git plumbing to get and collect the symbolic names like the tags or the branch names for a certain remote repository. You specify the repository URL, and if you have a commit ID with you, you can grab for it, and then you will see that specific version that you add in the Subtree commit corresponds to version 1.1. Because this is a little bit clunky and not that user-friendly, I'm actually working on a small improvement to Git Subtree, which will be submitted to the Git core mailing list soon, to make this a little bit more user-friendly. So I have the patch ready. It's approved that I can submit it, and we'll start the conversation about it probably in the coming weeks. Now, those commands were a bit long, so you know that in Git you can define your own aliases. So I wrote, now I'm covering, can you all see it? Yes? You can define your own aliases in a file called .gitconfig, in a section called alias. See, a section called alias. So I have created a couple of aliases to make this easier to remember and to type. You don't have to memorize it. Actually, I give you a short URL that you can go and check, and there's a few aliases there, including the ones that I use for Subtrees. If you use these aliases, the result is you can use a command. When you want to inject a dependency, you can do, shall I go back? You were taking a picture? You can take a picture again. You can type git subtree add the repository and the folder, and the work is done for you, though that dependency is going to be added to that folder automatically. Now, is Subtree the solution for all your project dependencies, troubles? No, the answer is no. There's a few situations where you might not want to use Git Subtrees. So I'll give you a few so that you know there are some caveats to the use of Git Subtree. When you should not use Git Subtree? So when you have many dependencies, and with the size of projects growing, and if you have a major big project, you probably don't want to use Git Subtree to manage those dependencies. I'll tell you what to use in a little bit. Because then you would need to go and run Git Subtree for every update to each one of your libraries. If also there's a question on how often do you need to update those libraries. If you have to update a library every day, then you will clutter your commit history with a lot of these commits and pulling the dependencies every day, and might not be exactly what you want. And if the entire team needs to learn Git Subtree because everybody needs to update libraries every day, that also counterfeits one of the pros that I mentioned before, which Git Subtree, only one person in the team needs to learn it because nobody needs to actually interact with it. If you use Git submodules, you always need to know how to update the submodules, and that applies to the entirety of the team, while with Git Subtree, that's not the case. But I've done this speech a few times, and let me warn you that whenever you were talking about project dependencies, there are proven ways to deal with them. And a lot of people had asked me in the past, how do I do project dependencies with Git? And my answer has been, if you can, do not use Git for project dependencies. I just showed you how you can use Subtrees for it. But in more general, broader general terms, if you use Java, obviously you used to use Maven, which tracks your dependencies, your versions, and can create releases for you. If you use Ruby, you use Ruby gems. If you use JavaScript, you have NPM, Bower. There's many solutions to project dependencies beyond Git. So this is just to say, if your dependencies are very complex, remember there's a solution tailored for each of your technology stacks. The second use of Git Subtree is to extract a project from a repository to create a standalone project. And I think it's a very, very cool way to use Git Subtree. As you can see, I can choose fancy GIFs, and I like this one, and a parting of the seas. So imagine you have a library that has grown enough, or a part of your project that has grown enough, and it's isolated enough that you can detach it and make it standalone. You can use Git Subtree to extract it. How do you do it? Git Subtree split. You specify the folder where most of that project is. Probably you want to move everything to that folder in your project. So you specify where that future repository is actually storing its history right now. And you specify the branch where you want all that code to reside. So Git Subtree temporarily, at least the command will actually store all the files in that folder and recollect all those commits, rewrite the commits only to include those files, and put everything in a branch. In this case, we call this branch extracted. After you've done this, the procedure is relatively simple. You delete the folder from your current repository. Hopefully, you will not use it anymore, and you will import it from via some other mean. Then you will initialize another empty repository where you pull this branch that you've just created. So you're just going to do pull, from the path of your parent repo and the branch that you want to pull. And after that, you can treat that as a perfectly new Git repository. You can add an origin, push it somewhere else as a master branch. And you have extracted the dependency from a big project. And I found this a very useful use case for Git Subtree. So I encourage you to try it out. OK, this was about Git Subtree. I hope I gave you some idea of how useful it is. And you'll tell me. I see very mean, angry faces. No, it's a cool, right? It's cool. I hope you liked it. So the second part is about interactive commits. So, I like this. I see them. I spent a lot of time looking for these animations, so you should clap. No, I'm kidding. The reason for it, I've already explained it to you, but I will just go through them so that you understand why you might want to split a commit as you're creating it. So there's a first prerequisite, and maybe, hopefully you agree with me, that every commit should be about one piece of work, one change, should be an atomic thing, so that you know that commit did one thing, it did it well, and it did it in a way that's documented. So the history of your repository should be readable and understandable by the developers that are working on it. So sometimes that's not possible because you're working on many things at the same time. So splitting interactively a commit, that might help you there, cleaning up your history. So if you know this technique, that means as you're committing stuff, you decide what goes into the next commit or not, frees you from the worry of saying, OK, first I need to work on feature A. I cannot work on this bug fix at the same time, because otherwise then how do I commit these two things separately? With this technique, you can. And it gives you much more fine-grained control over your commits as you work through them. So to explain you how this works, I'm going to work through a very simple example. And because I didn't want to make an assumption that you all guys know languages and stuff, we just speak a very simple, maybe walk down again, a very simple text file in Markdown where there's a title and a subtitle and some conclusions. And it's a bit of a simple example just to show you the process. So don't get caught up too much into what I'm doing here. But imagine I do some amends, some changes to this file, and I add a line into the main section of the title, I add a line in the subtitle, and I add a line to the conclusions. And this, in a real example, would be I'm working on a feature, but I'm also fixing a bug. And I'd like those to be in two different commits. But it's in the same file, so how do I do it? That's where you use git commit interactive. So if you did this change, and you type git commit interactive, this is what you see. You see, so this screen can get scary. I don't know if you guys have ever tried it, but you have a lot of options. You see a list of files that you've modified, and what do those mean? So don't get scared. It's relatively simple. Each of these is a command that you can type to affect the changes that you're about to commit. So, for example, the status command, you can type S or you can type status, will show you what you did so far. So relatively simple. Update will actually add to the staging area an entire file. So say you have 3 files that have changes, you want to just commit the changes to a single file, you can do update file number 3, and then it will be added to the next commit. Revert, obviously, will undo the work that you've done on a file. Diff is very simple. It's similar to git diff. We'll just show you a diff to screen of a certain change, a certain file. Add and tract is when you have files that are not yet in Git and you want to add them, but you're doing it interactively, so it's cooler. And the actual, the gold nugget of all this is the patch command. The patch command will take a file, and you can specify line by line, or as should I say, hunk by hunk, what goes into the next commit and what doesn't. So if you type P, I'm just doing it very slow, and then we'll do it interactively together. If you type P, Git will ask you, oh, OK, so about which file do you want to talk about? Which file do you want to go through interactively? and you say the first file, number 1. You can also type a part of the file name. So if in this case, you can type R or README or just the number. And once you say 1 and then press Enter, Git will ask you, do you want to stage this hunk? And I know exactly what you're thinking, because I've been there before. You're thinking, stage this hunk? And I know the face you're making. And your face is like this. What? What does that mean? I know because I've gone through the same thing. So just to make it very simple, a hunk is just a way to specify just a set of lines that are closely stacked together. And it's one of the terms that the patch and diff use to determine, which lines you're talking, the diff command and the patch commands are working on. So this was just a preview. Now let's do an example about that specific file together. And let's see. I hope you guys can see. Yeah, it looks readable. So let's do it together interactively so it becomes clear. See, it's not that complicated. So, OK, so we have that modified file. I type Git interactive. And Git asks me, OK, I have this file which is unchanged. What shall I do? And I say, I want to patch it. So I want to decide interactively which parts go into the commit and which parts don't. Then I say, OK, I want to patch the file number 1. OK, I press Enter. Then I press Enter to say I'm finished. OK, and Git says the famous sentence, stage this hunk. So as you can say, Git has clustered those entire changes into one hunk. And it's telling me, so those 3 lines, shall I add them to the staging area or not? And this is not exactly what we want. We would like to go line by line. So there's a command of the interactive commit, which is the split. So I can type S, or split. And Git will say, oh, was this too big, a group of changes? OK, let me then go in smaller pieces. So I type S, and now it's asking me, OK, the first line, shall I add it to the next commit or not? Yes, we want to create a commit about changes to the title section. So I say yes. I type Y, Enter. And Git is going to go then now to the second change. The changes to the subtitle. This we want to save for another commit, so we say no. So I say N. And then we'll do the same for the third. We also want to save it for later. Say no. And now I think we're done, so we can quit. We can type Q, and Enter. And now Git has created a commit for us containing only the changes from the first line that we approved. The rest is still in the index, ready to be committed later. So we say, OK, I added the section to the title, and when I'm done, I exit. So now if I do type diff, you will see that the first line is not there anymore, because the first line has already been committed as a separate commit. So in fact, if I just check the last 3 commits, you see I have created a commit, adding a section to the title, and the rest still hasn't been committed. Now, this was a simple example to show you for a text file, but imagine this, doing it with code. It becomes a very powerful technique. Just to recap what I just showed you, if the hunk that Git chooses is too big, you can split it in and decide on a smaller number of lines by typing S or split. And once you're done, you specify yes to the lines that you want to add to the index, you want to add to the commit, and then when you're done, you'll be prompted for the normal commit screen. If you ever are scared, don't know what to do, you find yourself in that, you can just type question mark and enter, and you will be getting this big page of instructions. The thing is, now you know what most of the things mean. So now I told you, stage means that you want to add a certain piece of text to the next commit. You know what a hunk is, so now you know what those words mean. And you can skip a certain hunk, you can choose it, you can discard it, you can quit. There's a lot of options, and after a while, it becomes relatively simple to interact with Git in an interactive way. So I hope I taught you something new. If you hadn't tried it before, don't get scared if you get stuck in that dialog, just press Q and you are out of it. Yes?
Yeah, if you use your own attachment product like Subtree, it makes it really easy. This is...
Yes.
It's a nightmare.
Yes, yes.
But the GUI stuff is really great.
Yes, so there are some visual clients like Subtree that make preparing and deciding what goes into the next commit very easy. So if you're visually inclined, please try Subtree. It's free. So.
Actually, there's a similar question. Can you instruct Git to states blocks of code instead of line by line? Or is
So
it either line by line?
no. The hunks are groups of lines, and when you split it, it will still get more granular, but will not go to the line by line setup. It's incremental.
There's some kind of intelligence.
See, sometimes the patch command is a bit dumb, and you need to fiddle around with it. But there is some lee room, so it gets from coarse to granular as you go.
And I guess the solution is source tree.
So source tree, obviously, solution to everything. So try it out if you haven't yet. Okay, this was a small, brief, tour of interactive commits. By the way, the simpler way to do all this is to use interactive add. So if you know that a certain file has multiple things that should be split, you can just type git add -p, and you will skip all those these complicated, the complicated first part of Git Interactive, and you will only get stage this hunk as a question. So you can go through a single file with git add. So that's might be a simpler way to get used to this. The third topic I have for you is how to attach histories of two unrelated Git repositories, and why would you want to do that? And if you're wondering what is this, is somebody who took a gold Apple Watch and crushed it between magnets. Now you're asking me, why are you showing me this? I thought it was cool. No, but it was about collating, attaching repositories, so those two magnets get attached to themselves, so I thought that was funny. So why would you want to attach the histories of two separate repositories together? So the major use case is a scenario where a team is migrating to Git, and they want to start using Git as soon as possible, but you have a legacy or the rest of the code is still in Subversion, and after a while you want to pick up and connect your new Git repository with your old Subversion repository at one point once the migration is done. And for this, this command I'm going to show you works perfectly. Also, sometimes it happens that you have two repositories that actually are one project and should really be together. The git replace is one way to merge, to connect two repositories, preserving their histories into one project. And also, git replace can be used to really complicated things related to cross merges between different systems, but we will not go there today. I don't know if you guys know, but the Linux kernel, if you want to get the entire history of the Linux kernel, and you clone it from the usual kernel repository right now, you're not going to get the entire history of the kernel. The actual kernel entire history is stored in 3 different repositories, which you need to go and collect from 3 different parts. So originally, there was a technique to do this, which was per repository. So you had to get the list of those commits, save them in a specific file, and then your repository would string them together. But more recently, well, actually, since a while, since Git 165, there's a command called git replace that allows you to replace any commit with any other commit. And so just a very brief explanation, allows you to tell Git, whenever you see these unique commit IDs, replace it with this, and those changes, those swaps are actually tracked inside some refs, and so you don't lose them. So imagine, the scenario where this is useful is, as I said, imagine your team is really itching to move to Git, but you have a big code base that will take a while to migrate to Git, so you have a team that works on the migration to Git while your development team is already working to Git. So you get to a situation where you have two repositories. One is a shallow clone that now evolves with new commits, and you have some legacy code base which will be migrated to Git at one point. So what you'd like to do is to merge them into one and preserve the history. So you'd like this to happen. Well, the command to do that is very simple. It's git replace. Git replace the first commit with the last, and you're done. So that's very simple. Actually, that's how it works. So the only thing you might need to know is if you want shortcuts in Git, how to find out the first commit of a repository. So you know the characteristic of the very first commit in a Git repository is that it doesn't have a parent. So to find it out, you just say, show me the log, show me a commit where there are no parents, and you'll get the first commit in a repository. And if you want to get the latest commit in a specific branch, you can do it in many ways. Obviously, you want to tag it. So if you want to use the git replace first with last, you want to tag the first commit as first. And to find out the last commit in a branch, you can do it in many ways. One way is to say, okay, parse this commit ID, tell me if there's, so parse this symbolic name, tell me what commit is that. You get a certain commit, and then you can tag it as the last one. But that head will work in this case, because that's always the last commit. Once you have tagged the first commit, of the shallow clone and the last commit of the legacy repository, you type this command and you look at this fancy animation, and this will be done for you. Now, there's one extra thing, which is these swaps, these replacements, are stored into the Git tree. They are stored in refs, in a folder called replace, which will contain a list of all the IDs that you have swapped. And the good news is that your teammates will be able to see them, because you can push those refs as you would push any other branch. Now, obviously, this after a while might become a little bit clunky. So what people generally do after they've done this, they use a tool like Git filter branch or BFG repo cleaner to go through the entire repository and make those connections permanent, so that you don't need to use those replace refs anymore. So this was a relatively esoteric, advanced topic, but I thought it was interesting to know that whichever thing you need to do in Git, there is a command for that. And I'm always surprised by how many things I stumble upon as I study more and more Git. So this is, I think, what I had for you. So this is my final Star Trek reference. Don't be scared to explore Git and all the possible flags that you can use. I'm going to be here for a bit if you have questions. And I just want to thank you very much. And if you want to follow me on Twitter, that's my Twitter handle. Thank you. Thank you for your attention. Thank you. Thank you. Do we have time for questions? Hey, 10 minutes, maybe? Has any questions? Yes.
So with the Subtree, so you can incorporate a different project, but it still has its own head and everything.
Yes.
Can you incorporate it and then just make it part of this project, as opposed to it still being a sub-project? So you have two projects and basically you would connect.
So the answer is yes. It depends on your requirements. So for example, that project up to that point had a certain history. Do you want to keep import that history or not? If you do the add without the squash parameter, you will get all the commits of that project in your local project. So that is imported and merged, and the history is preserved. So definitely you can use it that way. So that's one of the uses of Git Subtree. I think in general it's not the most used way, but now that I think about it, it's a very, very fine use case. In general, what people do is they have to maintain a separate project, but they want to use that library in their own, and they can see the integration points by using Git Subtree. They can use Git submodules. They can use many, many different things. Other questions? No other questions? Then, thanks again. Enjoy the conference, and come have a drink with me. Thank you. Thank you.